What do you think of when you hear the word biology? Do you know what it means? Let's break the word down. Bio means life. Logy means the study of something. So if we put bio and logy together, we get the study of life. Now, let's look at some other words that begin with bio. Biography is the story of someone's life. Biodegradable means something that can be broken down by living organisms. A biologist is a person who studies life and living organisms. Now that you know the meaning of bio, let's learn about two more important bio words. The words are biomass and biofuels. Let's break those words down, starting with biomass. We already know that bio means life. Now, let's look at the word mass. A tire is made from rubber, and a car is made of metal. Both of these things are made up of matter. In fact, everything is made up of matter, including you. Mass is the amount of matter that objects are made up of. Even though a tire and a car are both made up of matter, the difference between those items and you is that you are living, and those other things are not. So, when we add the word bio in front of mass, we are talking about matter that comes from living things. All living things get their energy from the sun. Plants get it through a process called photosynthesis. Biomass, or the material from plants or animals, has stored sunlight or energy in them. This energy is released or comes out when there's a chemical reaction, like people eating those plants. The food is then broken down in your stomach through digestion. The energy is then released and feeds your body. That's why it's so important to eat good food. The better the food, the more energy it has to keep you moving. Some plants are grown for us to eat. Other plants are grown specifically to make energy in other ways. Their biomass or leftovers are converted into fuel. A tree is a great example of biomass. If you have ever seen a tree get taken down, you might have noticed that it is then put into a wood chipper. The wood chipper then takes that massive tree and turns it into tiny chips of wood and sawdust. Those chips can be used for mulch in a garden or for landscaping. They might be used to cover the floor of a playground or to barbecue. Sawdust can be used as cat litter and make particle board. Wood chips are also used as biofuel and can be burned to create heat, which is a form of energy. A tree can be specifically grown and then burned for its energy, or it can be used for something else, like building a home or a fence. The leftover wood can then be burned for energy. Because more plants and trees can be planted to replace those that have been used for energy, we call biomass a renewable energy source. This means it is a source of energy that we can create again and again. However, there is only so much land and water to regrow plants and trees, so it is necessary to find other sources that can be used for energy. Crops used for fuel are called energy crops or power crops. They are grown on farms in very large quantities. One of the most popular power crops is corn. Like wood chips, dry-shelled corn is also burned for energy. A gas called methane is produced when garbage in a landfill begins to rot. The methane gas can be used to heat homes and businesses. And did you know that methane gas from cow manure, which is a fancy word for poop, can also be used to create energy? So, if you're ever out camping and forget firewood, look for the nearest cow pasture. Now, let's take a look at our second bio word, biofuels. You are probably already familiar with the word fuel. Remember, bio means life, so biofuel is life from living sources. Biomass is used to produce biofuels. An example of biofuel is the leftover vegetable oil that was used for making French fries. Corn was the biomass that created the vegetable oil, and the leftover oil becomes biofuel. That oil can be recycled and used as fuel in cars and trucks. In fact, one owner of 4 fast food restaurants engineered his car to be able to run on used vegetable oil instead of gasoline. Not only did his car go, but the leftover oil was recycled instead of thrown away. Ethanol is another type of biofuel. It is often used in engines that usually burn gasoline. Ethanol is an alcohol that is used for energy. It is made from the biomass of grains such as corn, barley, wheat, grass, sugarcane, and several other crops. Two other types of biofuels are biodiesel, which is used in large trucks and tractors, and biojet fuel, which is used in airplanes. These fuels are made by processing oil, fat, and sugar collected from plants or animals. Besides biofuel, there's another kind of fuel called fossil fuels. Did you know what a fossil is? A fossil is a super old organism like a plant or animal that has been preserved in a rock. Well, fossil fuels are natural fuels formed in the earth from dead plants and animals that are millions of years old. We get fossil fuels out of the earth by digging, drilling, and mining. Fossil fuels like gas, coal, or oil are burned to make heat or power. Fossil fuels are used in school buses, cars, and trucks. They are also used in homes and business for heat and light. Fossil fuels are referred to as non-renewable energy sources. They are the opposite of renewable sources, which can be used again and again. Biofuel is different than fossil fuels. Even though material made from the plants and animals can be used to power things, just like coal or gas can, a big difference between biofuels and fossil fuels is that many scientists believe that biofuel is cleaner and better for the environment. Let's look at some of the advantages of using biofuels instead of fossil fuels for energy. They release less pollution into our air. Engines can run longer on biofuels. Biofuels reduce greenhouse gases, which are gases that trap heat and cause harmful effects to our environment. Biofuels are renewable, which means they can be replaced like a tree that can be replanted. There are different sources that can be used for biofuels. Using biofuels create more jobs for people who need work. And biofuels help us become less dependent on oil. While biofuels have some great advantages, there are also some disadvantages. They can be expensive to produce. The soil may have less and less nutrients when the same crop is grown year after year. Large amounts of water and fertilizer to grow these crops may lead to water pollution. If land is used to grow food for energy instead of for eating, a shortage of food might happen, which could mean that the cost of food could go up. Many people still believe that biofuels are a better and cleaner option to fossil fuels. But because there are still disadvantages, more research needs to be done on using them. Biofuels may become the energy source of the future. Maybe one day, you'll even own a car that runs on leftover French fry oil. Thanks for following Clarendon Learning. Be sure to subscribe.
Can you name some fuels that can be burned to generate energy? Coal, oil, and gas are probably the first that come to mind. In this video, we're going to look at another special type, biofuels. We have fossil fuels to thank for providing us with energy that has been used for many huge advances in society. However, they also have some serious disadvantages. Burning fossil fuels releases carbon dioxide, which is a major contributor to global warming. Sulfur dioxide gas is also released, which makes acid rain, damaging the habitats of organisms. And oxides of nitrogen are produced, which can cause lots of breathing problems, especially for people who suffer with asthma. With our growing global population of 7.5 billion, we have ever-increasing energy demands. We need more environmentally friendly, cleaner, renewable alternatives. So what are biofuels? Biofuels are produced from living matter. They have many advantages, but some disadvantages over burning fossil fuels. Biofuels are said to be carbon neutral. The amount of carbon dioxide released when they are burnt is the same amount of carbon dioxide used to make the fuel in the first place. However, some people argue that biofuels are using valuable land that could otherwise be used to provide food for the 800 million undernourished people around the world. So what are examples of biofuels? simply burning wood counts as a biofuel. As we've been burning wood for 600,000 years, there's not much I can say about it that you don't already know. So we're going to focus on a more complicated biofuel. Instead, biogas. Biogas. It's a surprisingly simple process to make biogas. Inside a sealed tank, bacteria and other microorganisms anaerobically digest different feedstocks in the absence of oxygen to produce biogas. This biogas can then be used for energy. The tanks, known as digesters, are just like big stomachs, with lots of microorganisms inside to help with digestion. Like a stomach, the digesters need feeding. One of the clever things is that the food can be plant-based material, like energy crops, specially grown for generating energy, or farm waste materials, like cattle slurry, or it can even be food waste, wastewater and sewage sludge. We can make a renewable energy from all these useless waste materials. How amazing is that? In go the feedstocks, and the microorganisms digest away and do their magic. The temperature inside the tank is either about 35 degrees Celsius, or it's hotter between 50 and 60 degrees. This depends on the type of microorganism inside the tank. Just like in your digestive system, the feedstock is stirred around inside the digester tanks to ensure the microorganisms are reaching the undigested material. The anaerobic digestion process takes somewhere between 14 and 40 days to complete, and results in biogas being produced, which is collected from the top of the digester tanks. Biogas is about 60% methane and 40% carbon dioxide, with some other trace contaminants. The biogas can then be used to generate electricity, or even better, it can be cleaned up, compressed and injected into the gas grid as biomethane. Inside the tanks, we're left with a waste product called digestate. Another fantastic thing about this process is that the waste digestate is a great fertilizer. It can be used instead of petrochemical fertilizers, so not only has renewable gas been produced, but an organic fertilizer is made. Bioethanol is another example of biofuel. It's made by allowing yeast to ferment sugar. The sugar source can come from sugarcane and also fuel crops like maize, wheat, and some grasses. The ethanol product can be mixed with an alkaline fuel like petrol or diesel and used to fuel cars. These mixed fuels can be 85% bioethanol and only 15% fossil fuel. Whilst fossil fuels are still being burned, significantly less fossil fuels are burned overall. This process works best in countries where lots of the raw material, sugar, is grown, like Brazil. So there you have it. Biofuels are a useful alternative to fossil fuels. They're not a perfect alternative, but they certainly have some advantages.
If you liked the video,
Forestry and agriculture are the backbones of many rural communities. Landowners grow trees and agricultural crops, and mills manufacture lumber. With every one of these products, the product itself has the highest value. Take forestry. The high-value fiber is used for lumber or paper. The leftovers, or residuals, material like tops and limbs, bark, wood chips, and sawdust, are called biomass and have little other purpose. Some farmers have no other choice but to open burn the unusable parts of their crops. Forest waste can be left on the forest floor or sent to landfills where it decomposes. All of these methods of disposal cause unnecessary carbon dioxide and methane emissions, greenhouse gases that contribute to climate change. But there's a better solution for these materials. We can use these residuals to generate renewable electricity to power and heat our homes and businesses. Not only does biomass create a clean energy product that helps promote healthy and resilient forests, but the reuse of this waste material combats climate change. Unlike fossil fuels, like natural gas and coal that, when burned, release new carbon into the atmosphere, the use of sustainably harvested biomass recycles carbon that is already part of a natural cycle. Trees that grow absorb carbon through photosynthesis. When that biomass is used to make electricity or heat, the carbon is released, but then reabsorbed by growing forests. Provided that forests are harvested sustainably and regrown, the carbon from biomass is a part of a closed loop. Biomass means cleaner air, more jobs, renewable energy that runs 24/7, and less CO2 and methane going into the atmosphere. It powers and heats homes, businesses, and electric vehicles. And it strengthens our communities and helps them thrive.
Biomass power in California. Shall we see this?
Yes, sir.
Yes, sir.
In the United States got its start here in California. It's growing strong not only across the United States but across the world. But in California, the industry is actually dying.
There's been ups and downs in it, but right now we're in a downturn. Everybody needs to recognize the environmental disaster we're sitting on.
Intermittent renewables such as solar and wind only operate when the sun is shining or the wind is blowing. Biomass, as being a baseload power, provides power 24 hours a day, 7 days a week, 365 days a year.
Biomass usually consists of 3 different types of fuel. One is urban diversion, which is construction demolition debris that comes out of urban areas. Another is agricultural trimmings, either orchard grindings, walnut shells. The third type of material is forest, and that's any material that comes out of the forest or logging industry that also doesn't have an economical use outside of fuel for a biomass power generation facility.
Most of the plants in the state began operation in the late 1980s with 25 to 30-year power purchase agreements. Those contracts are starting to expire. At the beginning of 2017, less than half of the available plants in the state will still be in operation.
Facilities like Tracy and others in the valley have shut down both last year and this year to where there's only a few existing biomass plants that are still operating. As those facilities begin to shut down, there's other challenges that Californians will begin to face. Increased fire risk, health hazards because of open burning, more material going to landfill. So there's a lot of benefits that these facilities bring in addition to the renewable energy that we generate each year.
I have the overall responsibility and oversight for the 18 national forests here in California. We're moving into the 5th year of a drought. And what that has done is that stressed the trees. It's literally overwhelming when you look at the condition of the lands from tree mortality. When we treat that landscape, what we do is go in and we thin the vegetation. And so for us, it's really critical to utilize this material rather than to just let it set. 3 years ago, we spent about $300 million just in California doing fire suppression. In 2014, we spent about $400 million. And last year, we spent $503 million. It would have been a lot cheaper if we could utilize some of this material for good, like energy from biomass.
We're in the agricultural, urban, and organic byproducts recycling business. Like the walnut shell you see behind me, we market it to the biomass plants for biomass fuel. If the biomass power plants have to shut down, we have a big catastrophe here. With all these biomass fuel, there's no place to go.
The California Public Utility Commission needs to move forward quickly with the overhaul of least cost best fit. They need to take into account when procuring renewable energy the societal benefits, the environmental benefits, the baseload benefits, and also the integration cost.
One perspective is that biomass costs more than natural gas or wind and solar. On the surface, it's a very narrow perspective in a greater scheme of things, because when you have wildfires, the public is still paying for that suppression. Biomass is necessary, and we need to stop looking at it as one-dimensional.
These facilities can reliably operate again as soon as we have power purchase agreements. We've been working with state and local legislators to this end, but have thus far been unsuccessful.
To not recognize the value of the biomass plants in the state of California, it doesn't make sense. This whole thing will come together real soon when all this material, the urban, starts going back into the landfills and we start burning the orchards. And when, heaven forbid, we have a fire in the Sierras.
There's a number of ways that we can talk about what these national forests is doing for our American public. Our focus is really on values like recreation, water, generating electricity. And so how do we tell that story in its entirety using all the tools available to us, including biomass and the energy created from it?
The biomass industry is a critical part of the environment in California to help keep it clean.